Alright, so now let's talk about the coding. So you have several ways that you can go about writing this code. If you have a PC and you don't have Xilinx, I recommend this free program Notepad++. Notepad++ is nice because you can tell it what language you're programming in, and then it can catch some mistakes for you, and you can make sure that you save things nicely so when you bring them into lab you've got them. Another option is this website where you can actually compile and run your code with a test bench, edaplayground.com. And what you will need to do, if you have not already done so, is to create an account. When you do create an account, you'll want to make sure that you use your LSU email address, because then you can use the good compilers. And I recommend when you start, let me just log out. Okay, so I guess I'm logged in anyway. Okay, so what I recommend is that you go to, I wanted to get logged out. Okay, well, regardless. Okay, so choose System Verilog, go to Examples, System Verilog. Just choose this first one, D flip-flop. This just gets everything set up for you, right? And then I would do copy, save it with a new name, and then you can delete all the code that's in here and put your own code in. And then you can test it from there. Okay, or a gold standard is if you have Verilog. Alright, so let's talk about what you're going to need to make this file. So I'll start with the Verilog. And when you're doing this, it's Arctic 7, CPG 236, speed -1, and then it's that middle one. I don't want to close anything. Alright, so I'm going to create a new design source. Make it a design source. Create file, I'll call it lab5 si. And then let's think about the things that we're going to want to have here. So we have 4 inputs and 2 outputs. I'm from here. I'm going to do it in, I'm going to do it here. So, okay, so we've got our 4 inputs, A, B, C, D, our 2 outputs, PR, and I'm going to define my outputs to be reg because I'm going to put them in an always block. And then if in that always block, I'm going to start with my multiplexer. So let's go back and take a look at the multiplexer from the previous video. So on the multiplexer, I do different things based on the values of ABC. So it makes sense to have a case statement and to have that case based on ABC. So I will do that. I will have case A, comma B, comma C. And then I'm going to want to tell it what all my possibilities are. And I have 8 possibilities, and they correspond to the binary numbers 0, 0, 0 to 1, 1, 1. And I will pause it so you don't have to wait for me to type all this. Alright, so, and then I realized as I was typing these in, you're going to have different values than me anyway, so you don't want to copy exactly what I have here in any case. Okay, I'm going to save this. Alright, and so for each case here, so I'm going to tell it, I need to have a begin and an end because I'm going to define both my P and my R here. And so if you recall from our multiplexer, I said that when ABC was 0, 0, 0, P equaled D and R equaled not D. So if you go back and look, when ABC was 0, P has the value of D, R has the value of not D. If you look when P is 1, when ABC is 1, P is not D, and R is D, so that should be what I have here. Now this is just for mine, you will have different values for yours. And so forth for each one. Okay, so that's it. So that's our case statement, and that pretty much defines everything. That'll be end case, and that'll be end module. If you did that in Notepad++, and you put it all in, if you define the language, if you look, it's not lined up neatly, I guess because I didn't have it lined up neatly when I pasted it in, but look how nice it has the, so nice, so it's all, I can get it all lined up, which makes me very happy. Kind of not necessary at this point, but if you ever bring me your code to check, I do like it to be indented nicely. And you have to with Python. Okay, I'll stop. Okay, so said I'd stop. I can't help it. All right. So anyway, so that's all you have to do to get for the source code. Now, if you want to check it either in Vivado or here in this online, you will need a test bench, and you're supposed to have a test bench anyway. So let's talk about what you would need to have in your test bench. So in Vivado, you'll make a simulation source. The nice thing about this is that you can use the same simulation source for both the multiplexer and the decoder, because you've got the same input, same output, so it should be the same. So what do you need to have in your test bench? So you'll have the time scale, and then you'll need to give it a name. Anything that is an input in your main module should be a register here, so reg. Anything that is an output in your main module should be a wire here. And then this name right here, lab5, has to match the name of your module right here, or in Vivado, your lab5, or whatever you name your module here, right there, has to be the same as what you put here, right there in your test bench. You don't have to call it UUT, it's unit under test, but that's what I call it. Now, I tend to be careful and use the same order of variables here as here. So these variables are the same in the same order. I used capital letters over here and they're lowercase over here. But that just means capital A is A, capital B is B. If you can use a dot notation, which you can see in one of the lab handouts if you don't want to make them all match up with order. Okay, then you have to initialize, so you'll have the initial. And then these two lines are just telling it to display something, and this is just going to print exactly what it has here on the screen. So that's just does it once in my initialization. And then I set A, B, C, and D all equal to 0. The point of the test bench is to run through all the possible values of A, B, C, and D to make sure I get what I'm supposed to get. Then I have an output. In my output, I'm going to display the values of A, B, C, D, P, and R. And that's this part here, A, B, C, D, P, R. Those are the variable names. I'm going to display them. In quotation marks, I have placeholders for those. The %D means as a decimal. They're all 0 or 1, so I could have used %B just as well. So for every variable, I have a placeholder. So for A, I have a %D. For B, I have a %D, and so forth. I have a little vertical line here. That vertical line is just showing me the marker between where my inputs end and my outputs are, and you'll just see that as we run it. It just gives me something to look at. And it started at 0, and it says if it gets to 1, 1, 1, 1, then that indicates, oops, that was just a comment, so it doesn't matter, that indicates that we are at the end, we've done them all. And in that case, it'll display end, and it'll display finish. Otherwise, it will add 1 to A, B, C, D, so it'll add up, and we should see what the output is each time. So I'll save it and run it. And I can see my output right here. So based on my values of A, B, C, and D, I can see what my values of 0, of P, and R are. Now if you remember what we defined in the previous video, I said P is equal to min terms 1, 2, 9, and 10. Well, let's take a look. P, here's 1, here's 2, and P is 1 for both of those. Here's 9, it's binary for 9 and 10, and I get 1 for both of those, and I got zeros everywhere else. And my values for R are correct as well. So R was supposed to be 0, 3, 5, 10, 11, 12. 0, 3, 5, 10, 11, 12. So that worked. Let me go back to Vivado because we're not quite done here. Now, so in Vivado, if I have my test bench and okay, even with just the source code, I don't have to have the test bench yet. With the source code, I can do an elaborated design and take a look at it and see if it looks like what I'm expecting it to look like. And it does. I've got these multiplexers right here. I've got A, B, and C are my inputs into my multiplexers, and then I'm doing something with D to define what the output should be, so that looks pretty good. If I have put my simulation source in, so I've got my test bench in here, I need to make sure that is set as top, and then I can run my simulation, run a behavioral simulation. I like the printed output, so you also have the schematic output as well. I'm terrible at, I have a hard time reading it. So I'm not. Okay, but here I can see the output. And I've got my same output right here, and I can see what that looks like. Okay, finally for the constraints. So the constraints, you can do them as in, you can make your constraint file in Notepad++ and save it. And let's see, I think I have it here, yeah. So I copied the constraints template from the Xilinx site, and I also put a copy of it in the SI resources. And this has everything in it that you'll need, and you just have to uncomment the lines that you want. And so the lab directions said that A was switch 2, B switch 3, C switch 4, and D switch 5. So you would change switch 2 to A. So you change both those to A. Oh, and you uncomment them. Switch 3 to B. This is where I make my most mistakes, is doing those. And then, and so forth. And when you do, you can delete all the ones you didn't comment out if you want to. Or you can leave them in. So you'd have your A, B, C, and D, and you also had to define 2 ports. And this you can't do if you don't have a board, but you will do it tomorrow with your next lab. And when you get to this part, you would generate a bit stream. It's telling me that I'm already up to date, so I can just demo for you. So you generate the bit stream, and then you find out if you have any errors. And you open your target. I'm not going to spend time on this since you don't need it for your lab report. And then I also just realized that I don't have a camera turned on, so I couldn't even show you what it was doing anyway, so that's not very helpful. Okay, so now let's talk about what to do for the decoder. So you can use the same test bench and the same constraints. So those files, you can just copy those over. How is it going to be different? How is your code going to be different? Well, I don't know if everybody would do it the same way I would do it. But I decided what I wanted to do was to make a decoder module that I could reuse if I needed to. So let me show you how that worked. So I am reusing my test bench here. And I actually didn't run this on the website, so I hope it works. So I ran it on Vivado. So I have here, let me do this separately. Okay, so I made one module that really was just the decoder. So it takes your 3-bit input and it outputs an 8-bit string that has just, it's one hot, it just has one, oh look at that, I'm missing a 0. It just has one 1. Oh, this shouldn't have worked. But it did. Anyway, okay. So it just has one 1 in the position that would tell you what the values of B, C, and D are. So I gave it B, C, and D. I defined F as a vectored signal, an 8-bit vectored signal from bits 0 to 7. So this is bit 0, and then bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7. And if B, C, D together made the value 0, I put a 1 in the 0 bit. If 0, 0, 1 made the value 1, I put a 1 in the 1 bit, 2 in the 2 bit, and so forth. And so this is just a decoder. And then I can use that in my main module. So then, see how we would use that. So in my main module, I have all of my inputs, A, B, C, D, and P and R. Now the reason it was B, C, and D is, if you recall, when we did the decoder took the values of B, C, and D, and then P and R were based on the values from that decoder, and then either A or not A. And then in my main module, F is the wire that I make using this decoder module. I called it lab5 decoder, so I instantiated a lab5 decoder. I called it decoder. I gave it the values B, C, and D, and it's going to give me the value of F. And now I had said that P was equal to either, if I had a 1 or a 2 in my decoder. So that made it equal to P equals F of 1 or F of 2. R was more complicated. R had to do both with the values from the decoder and with A. So R was the not of A. So if you remember, it was when A was 0. And then my decoder value had the values of 0, 3, or 5. So when the decoder gave me 0, 3, or 5, that should have been an OR. That should have been an OR. 0, 3, or 5, and not A, then that's one possibility for getting an output of R. The other possibility was when it was 3, didn't matter what A was, so that 3 just went straight into that OR gate. Or when I had 2 or 5 and A, so A and 2 or 5, so here's the 2 or 5 and A, and that goes into there. So then it becomes an easy programming. I say F, I sent B, C, and D to my decoder to get the values, and then if F of 3, that's one possibility, or if F0 or F5 and not A, that was this top one, or F2 or F4 and A, that was the bottom one, and then that gets me my value. And out of curiosity, let me see if this runs. Let's see, I need to make sure I have the right name. This should be lab5 main. It works. Okay, so all right, so that is your help for your Lab 5 report. Let's take a look at what you're supposed to do in your report itself. Okay, identifying information. What was the purpose of the lab? So you'll need to figure all that out. What results did you obtain? Answers to questions asked in the lab description. Screenshots, if any or part of your lab didn't work, why? Code files, and figures and screenshots to enhance your report. So even if you didn't get it working in the lab, you can get a whole lot of it working just using the stuff that's available outside the lab. All right, if you have any questions, email me.